Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we inject weird and wonderful science directly into your genes. I'm Ian Woolf. On this edition, Gavin Huang talks about students building and launching satellites. And Meow returns to talk about Mars jars. But first up, here's the news about aging, DIY, and snooping robots. Do-It-Yourself Day is coming. The Museum of Applied Arts and Sciences DIY Do-It-Yourself Day will be held on the 19th of August 2017 in Sydney. The DIY Day inherits the mantle from the very successful Sydney Mini Maker Fair held in the last few years. The DIY Day features workshops, talks, classes and displays by the maker community. There'll be a repair cafe where you can bring broken electronics and be shown how to repair them on the spot. You can come and see displays from regulars like the Australian Electric Vehicle Association, Makerspace, MathWorks, Mobile Makerspace, Sydney Modern Quilt Guild, Sydney Origami, and the University of New South Wales CubeSat team. The CubeSat team launched two 1.3 kilogram satellites in April. The DIY Day on the 19th of August is part of this year's Sydney Science Festival, running from the 8th until the 20th of August with over 150 different science events. You can find out details at sydneyscience.com.au. Aging is controlled by your brain. Researchers at the Albert Einstein College of Medicine in New York have discovered that stem cells in the brain's hypothalamus govern how fast aging occurs in the body of mice. In 2013, the team discovered that the hypothalamus had this role in regulating aging, as well as growth, development, reproduction, and metabolism. Now in 2017, they've pinpointed the mechanism to a group of adult neural stem cells in the hypothalamus. The number of these neural stem cells decline as we age. The discovery could lead to new treatments for age-related diseases and perhaps slowing or even reversing aging in humans. The number of hypothalamic stem cells began to diminish when the mice reached about 10 months, several months before the usual signs of aging start appearing. By old age, about 2 years old in mice, most of these cells were gone. Did the loss of these cells cause the aging symptoms? To find out, they disrupted the hypothalamic stem cells in middle-aged mice and saw them age rapidly. The hypothalamic stem cells appear to work their anti-aging effects by releasing molecules called microRNAs, which tell which genes to switch on and which genes to go silent. MicroRNAs are packaged inside tiny particles called exosomes, which hypothalamic stem cells release into the cerebrospinal fluid of mice. The researchers genetically engineered microRNAs to survive in the inflammation-inducing environment of an aged hypothalamus, and then injected them into the cerebrospinal fluid of middle-aged mice with disrupted hypothalamic stem cells and in normal old mice. This treatment significantly slowed aging in both groups of animals as measured by tissue analysis and behavioural testing that involved assessing changes in the animal's muscle endurance, coordination, social behaviour and cognitive ability. The researchers are now trying to identify the factors secreted by these stem cells that are responsible for the anti-aging effects. The paper was titled, "Hypothalamic Stem Cells Control Aging Speed Partly Through Exosomal MicroRNAs," and was published in the journal Nature. Our appliances are spying on us. Roomba robot vacuum cleaners have been collecting your data with your dirt. The CEO of iRobot, The manufacturer of the Roomba automatic vacuum cleaner announced in an interview with the news service Reuters that the vacuum cleaners have been recording maps of people's homes and that he plans to sell that information. While they've been cleaning, the robot vacuum cleaners have been collecting the dimensions of a room as well as the distances between couches, tables, lamps, and other home furnishings. The cameras have also been photographing your rooms. Companies like Amazon, Google, and Apple could use the data to recommend home goods for customers to buy. Doesn't that sound like fun? It could be a very attractive archive of data for thieves to crack into. The CEO said that he expects most people would consent to sharing information about the layout of their home in order to access the smart home functions. Does that mean that you can't access those functions if you refuse consent? The first Wi-Fi enabled Roomba went on sale in 2015, which is when they started mapping people's homes and beaming the data back to iRobot. This is how the vacuum cleaner was able to adapt to people moving furniture around. Rhett Jones at Gizmodo points out that iRobot don't actually need your consent to sell your data because hidden in legalese in the Roomba terms of service and privacy policy, you agree to allow iRobot to share your information under all kinds of situations. Most people will click agree to get the full functionality of an expensive device they've just bought, and mapping information does make for a better robot vacuum cleaner. You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. Next up, Gavin Huang is a third-year engineering and marketing student at the University of Technology, Sydney, with a passion for space. He's an organiser of the Orbit Space Entrepreneur Meetup and president of the UTS Professional Aeronautics and Astronautics Society, PASS, P-A-S-S, which is a student branch of the American Institute of Aeronautics and Astronautics. The BlueSat project at the University of New South Wales involves building CubeSats, ground stations, and rovers. The UTS Professional Aeronautics and Astronautics Society is collaborating with the University of New South Wales BlueSat team to send something into space. I visited Gavin at UTS and began by asking him, what is he sending into space?
So we're sending a payload which is 10 by 10 by 10 centimeters, and it's pretty much a small cube which has pretty much the same chips that you'd find on a phone. So including accelerometer, gyroscope, thermometer and pressure gauge.
And is it going to go up into space on its own?
So we're working with a startup rocket company called Ripple Aerospace. They're a Norwegian startup company, and they're sending our payload on a sounding rocket called Sea Serpent, which is an aerospike rocket which is going to be launched from Florida, 20 kilometers off the coast of Florida.
And what's a sounding rocket?
So sounding rocket's pretty much a rocket which the sole purpose of it is for science experiments, and it is a suborbital hop, so it doesn't actually orbit around Earth. It just goes into space for a couple minutes and then comes back down.
So how many CubeSats will be sent up, do you think, with yours?
I think there's room for 6 more 1-unit CubeSats, so potentially 6 other ones.
And what are you going to do with all this information?
So the information itself isn't going to be used for much. It's just the proof that we can actually send something into space. So we just needed something simple to send to space. Given our time span, we only had 1 month to build it. So it's 1 month to actually get everything ready, and then there was a delay, which was delayed by a couple of weeks. And so because of the time span, we couldn't do anything special about it. So we just grabbed simple electronics, put it in there, and proved that we can actually do something basic.
And your cube is 3D printed?
Yeah, so the cube is 3D printed. Initially, we thought 3D printing was the answer to everything. We thought it would be cheap. We thought we'd get everything done, but it took us, I think, 1.5 weeks. Every day we came to uni to make sure it was down to the rocket company's requirements, which is the 10 by 10 by 10 centimeters, 100 millimeters each side. And it took us a lot of reiterating, and 3D printing was good for prototyping, but not for actually a final product. That's what I'd say on the CubeSat.
And the BlueSat project's been around a long time.
Yeah.
How long has it been around?
I think since 97, I think 20 years from what I'm told. BlueSat's been here for 20 years.
So after 20 years, it's finally sending something up and you had 2 weeks to get it ready.
I think they've sent other stuff into space before. I'm pretty sure with the older people from there, but with Taufik and the people I'm working with, I think this is probably the first thing they've sent to space. Yeah, so it was really fast for us. So it took us, I think, because my society, PAS, PAAS, Professional Aeronautics and Astronautics Society, that was founded this year, and we've had 6 months. We've just been doing stuff for 6 months, and then after that we sent something to space.
It's a very quick turnaround.
Yeah, extremely quick. Yeah, it really baffles me. Like, I'm not sure it was good luck or good coincidence that I knew people. I think a balance of willingness and networking and luck that there was a rocket company which needed something to put on there. I think a combination of all of it.
So how did you get in contact with Ripple?
Oh, okay. So we had the space panel night. You were there. So I think one of the people there called Dean Little. He's an engineer for Ripple, and he was at the space panel night, which I organised under PAS. After that, he really liked what my society was about, and he wanted to provide us an opportunity to send something to space. And from that, he sent me an email with Sebastian Chowie, said, I got an opportunity for you, and you can put something in space.
So once you've sent this object into space, that's basically just proof that you can.
Yeah.
What's the more interesting one you want to do?
Oh, I don't even know, because I do orbitals because I want to do entrepreneurship sometime in the future, but because space is so broad, you got agriculture, you got Earth observation, Earth observation, you got space exploration, you got trying to fix climate change, you got so much with it, and I don't even know what I want to do next. I think the next launch is 2019 with Newman Space, so they're going up to the International Space Station, 2019, and I hope I can work with the same people, even new people who are keen to, I don't know, it's specifically with an objective. I don't know what it is, but 2019 is the deadline. Maybe centrifuge. That's something in my mind, just to see if we can recreate gravity in space.
So do you have an idea for your own startup yet? Because you're so involved with all these space entrepreneurs.
Yeah, a specific idea, not so much. Because with entrepreneurship, it's a lot of it's for fixing businesses. I want it to be improving people's lives, like our daily lives. You got GPS, you got satellite communications. That's probably as close as direct impact that you can get. But I don't know. I don't know what that. Hey, I've created something to fix someone random's life because of space. I don't know what that is yet.
So I've heard the idea that they want to introduce people to imagine a month without space, to give people the idea of just how much space is involved in their everyday life.
Yeah.
How do you think we can get across to people just how important space is to how they live their lives and how they could live their lives?
You can just take it away. Just hope for a solar flare or something like that. Okay, I'll start off with GPS, for example. Yep. Satellite communication. You don't have GPS, you don't know where you're going to go. I mean, planes are going to fall out, planes are going to go everywhere, ships are going to go everywhere. You don't know how to get to your mate's place. Without space, you can't do a lot of stuff. The mammograph, that was from indirect innovation from space technology. There's just so much.
Because that's one of those things. Every time someone says, let's have a space agency for Australia, you get a chorus of people saying, we need to spend the money on Earth first. Look, we've got all these homeless people. We've got all these problems to solve. How can we waste money on a showy thing like space?
So my answer to that, it's always been on my mind. One day I'm going to get that question. Today I've got it. So my answer to that is there's problems everywhere. There's famine, there's war, there's climate change. But with space, I thought of another answer. With space, you can use space for defense. So you can see where the opponents are in a war. Climate change, you can figure out the data about high polluting countries. Famine, you can figure out weather, and you use that information to make sure we don't have famines or droughts. And if you have that, if you have a famine or a drought, war will occur. So that's my first answer to that. And the second answer is, if there's always going to be problems. I think it's each to their own about what problem means the most to you. I think there are people out there who do charities for like helping others, which is great, and for them that's their problem. But my problem is that space exploration is such a key part of our innate human condition. I think our curiosity is what makes us innovate. I think our curiosity to do the next big thing, do the hard thing, I think that will fulfill true human nature. So Carl Sagan, he did the pale blue dot. If you have a look at the image, that's only a couple pixels wide. And what he's saying is that from Saturn, so the photo was taken from Saturn, and you see just a small dot. It's when you look at it, you think that's just a star in the distance, but that's Earth, and you realize how insignificant we are, and how all of human civilization, from the caves to our high tech lives, that's captured in just a couple, like just a few squares wide. And I really want to convey that you are small, but because you are small, do something in life which is significant, which can help our pale blue dot.
Well, Gavin Huang, thank you very much.
Thank you so much.
That was Gavin Huang, building and launching a nanosatellite in just 2 weeks. And finally, Sydney biohacker Meow Ludo Meow Meow returns to tell us about the Biofoundry's latest projects, including Mars jars. I visited the Biofoundry and began by asking Meow what's bubbling in the Biofoundry.
So what projects do you have on the go at the moment? What's the new startups? You're planning a trip overseas. What's going to happen?
So what's bubbling in the Biofoundry laboratory? So we're very interested in the moment at isolating some strains of algae from the wild. So this is pretty cool because this is a good introductory project. So if people don't know where to start in biohacking, I often encourage them to start small, really, really small, microscopic. So we encourage people to bring in some environmental samples, and we can start doing some techniques to isolate the microbes out inside them and build a cultural library. This will be for free distribution to educational facilities, and we'll charge if people want to use it commercially, because there's actually very few commercial libraries of microorganisms in Australia, and this can hold back business. So it's a good way for us to get people in, train them up on basic techniques, and then also give them a chance to sell, to make some money, and hopefully make some money for Biofoundry, while also providing good commercial outcomes for the people that might want to do things like bio-oil and extracting interesting compounds from the microbes. So that's probably the first one that we're working on. We're teaching a lot of courses. Everyone's welcome to come. We have a no one turned away due to lack of funds policy. So if anyone can't afford it, please just get in contact with us. We have plenty of volunteer work you can give us a hand with setting up the course. And we're trying to live stream a lot. Currently working on a hackathon, which we're a bit hush-hush at the moment. But between you and me, it will probably be in November, and we're looking at doing something on the scale of kind of hackathon, about 150 people, and looking at those 5 pillars of biohacking. So there'll be something for everyone, is the old adage. But basically, we're a bit upset about most hackathons exclusively catering to programmers. And we want artists, writers, lawyers, mechanical engineers, biologists, and people who use computers, but there's a lot more to the world and hacking than just code. And I think that the most exciting things are the intersections between all the different disciplines. And the whole point of hacking is you're meant to unsilo your thought and take on all these different things, and then you go to these hackathons, and it's like, oh, where's your laptop? And it's, you actually just put yourself in another silo. One of the most exciting things I saw at Hackathon one year was a guy deliberately didn't bring his laptop because he wanted to see how much he could do without one. So he was programming an Arduino from his mobile phone. So it's really, really cool, and I love seeing that. And I think as well, the skills that you have in hacking and the way you attack problems is just as useful for a performing artist, a writer, a person who wants to finish off their thesis, as it is for a coder or a biotechnologist. So we're also working on ways that we can commercialize some unusual edible fungi, and some of them might actually have some interesting neuroregenerative properties. We might have talked about this one before, but we're working out ways to bootstrap that. But the main technology that we're building with that is actually the equipment around it and not the fungus itself. So we're doing it with a couple. We've got our palm oil yeast as well. They're sharing some equipment. So we're looking at how do we take waste products like plastic 44-gallon drums, the 200-litre barrels, and use them as an incubation container. So normally we chuck all this stuff out. Are there things there that we can turn into low-cost, inexpensive and randomized kind of containers that we can hodgepodge together into a really powerful biotech facility? And that's where the IP and that kind of is. So it's as much for the end product as it is for the things that we make along the way. And I'm also working on a simulated Martian greenhouse. So it kind of came out of this idea I've had for a long time, which was initially called Mars jars. And it was meant to be this little piece of Mars in a jar, super low cost, and you try and grow things in there. It's evolved across like the past 4 years. Initially I got offered $25,000 from DARPA to get this project done, but I was at university, I didn't have time. And now I've got a bit more time, we're rebuilding it, reimagining it. I'm working on it with a Melbourne biohacker from Bioacquisitive called Michael Flood, and he's doing all the industrial design and user experience, and I'm doing the kind of the theory and some of the prototyping. He's doing a lot of the prototyping too. Basically, at the moment it has an Earth atmosphere with Martian soil, but you can control the parameters inside. So we're not going to take dirt with us to Mars. It's very, very heavy. And whenever we're going to other planets, we have to think about the amount of money it takes to lift it off the planet out of the gravity well. But we can take things like hydroponic lighting, plastic sheeting, and if anyone's seen The Martian, that's basically what they did. They took basically a greenhouse and they took the dirt from outside. While I was building this, I started to do a lot of research on the Martian soil. We call it regolith. And I found a Martian regolith simulant that I can obtain. And I spoke with some people from NASA, and they confirmed that this one's pretty good. So we're building that, and hopefully that will be available before the end of the year. It will definitely be available for beta purchase. So if you're a hacker, please get in contact with me. And I'm looking for people to hack the best possible one together at a low cost, and then there'll be a commercial version released after that, which is for just someone who wants to have a little Martian greenhouse on their desk.
Will there be a way to put a Martian-style atmosphere in your Mars jar?
That is later on down the track. So after the first iteration, it will be a very safe Martian regolith simulant. Version 2.0 has toxic Martian regolith simulant, so it's going to have perchlorates added, which is a big problem for when we go to Mars. It's not going to be for sale to kids or anything like that, but parents could buy it. One interesting thing, though, is that perchlorates is chlorine with 4 oxygens bound to it. There's bacteria that can liberate those oxygens from that. So I want to give people the ability to do some basic bioprocess engineering and terraforming in their house by putting this toxic chemical in them and letting them work out how to work with it. It's not that bad. It's only if you have continuous exposure to it. But if we're going to go and terraform another planet, we need people to be practically experimenting with that here. So that will be number 2. And then number 3, I'll be pumping the oxygen out, be chucking a little bit of carbon dioxide back in, replicating that Martian atmosphere. And then we'll see, with all those things combined, stick it in the freezer and see if we can get anything to grow. But I think the thing is, we've got to think about what are the conditions that stop us from growing things there. So we can make an atmosphere. If we don't have it, we know we can make it from the soil. And then things like the cold are almost impossible to get around. But how many degrees do we need to raise it by? How much does that change with pressure? It's, in some of the places in Mars, it's like, hundreds of degrees too cold. Some places like, under minus 116. So it's really, really cold. But if you can get it to minus 80, all the carbon dioxide sublimates and turns into gas, then all of a sudden it gets warm very, very quickly. In fact, it's the exact thing we don't want to do to Earth, putting carbon dioxide in there and having that runaway effect. So that's the questions that I hope people start working with. And then eventually, if there's any talented web developers out there, I'd love to have a back end where everyone can share their results, maybe download different conditions. Maybe you could say, I've just programmed what it's like at the top of Mons Olympus, and you could just punch that in, download that, and it would change the conditions, and someone else might say, and this is what it will look like 13 years into our terraforming effort. And you could download these things and share them with everyone so that collectively we can work out what happens when Elon lands us, because I don't think he's thought too much about that.
Meow, thank you so much.
No worries, it's been my pleasure.
That was microbiologist biohacker Meow Ludo Meow Meow. You can find out more at foundry.bio. And a big thank you to John from Sydney for his generous donation. And that's all from us this week on Diffusion. Would you like to hear your voice on radio? Record a voice memo or use the voicemail tab on the Diffusion website. We need more people contributing stories. Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com, and please do send me an email so I know you're listening and you'd like to hear more episodes. Please like the Diffusion Science Radio page on Facebook and rate the show on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. Join my patrons in supporting the show at patreon.com/diffusionradio. The news music was Rynos theme by Kevin MacLeod of Incompetech.com. Checking production was Charles Willock. I produce Diffusion, which is broadcast around Australia to 27 stations on the Community Radio Network, including 2 RBM in the Blue Mountains of New South Wales, 8CCC in Alice Springs and Tennant Creek, 2 NVR in Nambucca Valley, and 3 MBR in the Mallee Border districts of Victoria and South Australia. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to our podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 900 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Subscribe to the Diffusion YouTube channel at youtube.com/c/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Our planet is a lonely speck in the great enveloping cosmic dark. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.